Okay, time for a worked example. Now, very importantly, before you watch this video, you need to do the question. So have a try. If you haven't tried it already, stop the video and do the question now. Okay. And what I'm going to do, again, it'll make a whole stack more sense to you if you have actually tried it, so it's a bit of a waste of time to watch the video if you haven't done the question yet, because I'm going to go fast, I'm not going to read all the details. So it's a rates question, and one of the reasons I chose it is because it's got just about a little bit of everything. It's got a bit of definitions, got a bit of experimentation stuff, got a bit of collision theory, a bit of graphs, a bit of stoichiometry. It's a very nicely well-rounded question. So the first thing they ask for is typically, they often do, define reaction rate in words. Now I sort of gave you a bit of a hash definition in the previous video. The one thing I don't know if I emphasized enough is it's the change in the concentration of products or reactants per unit time. So on the one side you've got to talk about the change, on the other side you've got to mention the time. So change in concentration of products and reactants per unit time. Then this experiment, we've got the equation up here on the board, calcium carbonate with acid giving us carbon dioxide and other things. And so it fizzes away in there, it's going to be producing gas, and we would be collecting that gas, and that's the gist of the experiment. And there were various different conditions that they did it under, which are sort of summarized in this table. I've just done the very bare minimum there so that you can have a quick reference on the video. And they ask us a few questions. So 5.2, the results of experiments 1 and 3 are compared in the investigation. Okay, so 1 and 3. So we're looking at these ones here. So, only thing that's different is the temperature. They're asking, first of all, what is the independent variable? Remember, the independent thing is the thing that we changed. The dependent is the thing that we measured. So the independent one is clearly, in this case, we changed the temperature, one made. So that will be the answer to 5.2.1. What is the dependent variable? Well, the whole objective of the experiment, as you would have read, is to measure the rate of reaction. Okay, so that would be quite fine to put as the dependent variable. You could put, because we are looking at volume of gas produced, you could put volume of gas produced, but don't forget it's not in isolation, it's per unit time to bring in the whole rate side of things. Okay, so either rate of reaction or a volume of gas produced per unit time would be the dependent variable. Then we move on swiftly onto collision theory. Use collision theory to explain why the reaction rate in experiment 4 will be higher than that in experiment 3. So in this case we're looking at these two. Okay, 3 and 4, I'll just do that this time. Same concentration, same temperature, different masses though. So you think back to that table that I took you through last time and you think, well, mass, what's mass? Mass, the thing is, if there's got more mass, it's bigger, and therefore there's greater surface area. So it's an increase in surface area is the first point. We've got to get 3 marks out of it. So remember, you work your way through, saying therefore there's more of the reactants exposed to each other, which will lead to more collisions, more effective collisions, and therefore a faster rate of reaction. So just sort of go through the logic of it like that. Okay. Then on to graphs. Okay, so I'll just quickly sketch up the graphs for you on the board, if I can. Put stuff down. So we're looking at volume of CO2 produced, and that would be in centimeters cubed, if the measurements there, and this is the time in seconds. Okay. And they give us a bunch of different options. Let's use colors. So A is fastest and the highest. Then B, almost as fast, not as high. Then C, a little bit slower still, reaches the same as B, and D, sorry, is the lowest, the slowest, but still getting to the same height. Okay, so those are our options. And the question is 6 marks. Woo! All right. Which one of the following graphs, A, B, C, or D, represents experiment 1? Fully explain the answer by comparing experiment 1 with experiments 2, 3, and 4. Okay, so we've got to think through our way that we're going to explain this. Probably 1 mark only for the correct answer and 5 marks for the explanations. So let's think it through. Let's compare experiments 1 and 2 to start with, because we're trying to identify which is experiment 1. So comparing experiment 1 to experiment 2, well, the difference is a lower concentration. So therefore, the graph for experiment 2 has got to be lower. So you would mention experiment 2 has a lower concentration, therefore the gradient is going to be shallower than for the one for experiment 1. Then let's compare to experiment 3. We'd say experiment 3, and in fact we could mention experiment 4 as well. You could say in both of these cases, the temperature is higher, therefore the gradient is going to be steeper. Concentration is the same. And in fact, in experiment 4, there's also a greater surface area because of the larger mass, which will mean it will be steeper still. So that is in fact likely to be the fastest of the graphs, and because of the greater mass, it's going to end up going the highest. So clearly, A is now our first definitive graph. A must be for experiment number 4. And then working backwards in our logic, we can say, well, also therefore B must be experiment 3. C is our experiment 1 because it's less than B but more than D. Okay, so you work through the comparisons, bring in the reason, and talk about the gradient. That's where the marks are. Okay, so compare 1 to 2, 1 to 3, 1 to 4, and as I said, look at the reason why it would be steeper or shallower, and talk about the gradient of the graph, and finally conclude C. So that's 6 marks there. 5.5, a bit of stoichiometry. Let's have a look here. So we'll keep that up just in case. We're told when a reaction in experiment 4 reaches completion, the volume of gas formed is 4.5 decimeters cubed. Assume that the molar gas volume at 40 degrees C is equal to 25.7 decimeters cubed. So normally it's 22.4, but in this case 25.7 because it's a bit warmer than standard conditions. Okay, so first of all, what we've got to do is think, well, what are we told? The 40 degrees is not a figure for us to worry about. We're interested in how much was formed, that 4.5 decimeters cubed of gas. So what we can have a look at there is that we can work out the number of moles according to V equals VM, V over VM. And so the 4.5 over the value that they gave us for the correct VM. So that is going to give us the moles of carbon dioxide produced, which, if I remember correctly, is 0.18. Yeah, 0.175. Let's just use 0.18 moles. So that is the number of moles produced. By the way, I didn't read the question in full, but as you probably saw yourselves, what we're actually trying to find is calculate the mass of impurities present in the calcium carbonate. So tricky little question that you've got to bear that in mind when we get towards the end. So we've got moles of carbon dioxide. We go back to the chemical reaction, carbon dioxide to calcium carbonate. Cool, it's a 1-to-1 ratio. So you can say that CaCO3 to CO2 is 1 to 1. Therefore, if we've got 0.18 moles here, well, you're going to have 0.18 moles there. Okay. So then we're now going to work out, well, how much is that worth? So then we're going to look at N equals M over M. And the moles is 0.18. Our mass is what we're trying to find out. And our molar mass, calcium carbonate, calcium is 40 plus 12 plus 3 times 16, which is 52 plus 48 is 100. Okay, so that then gives us the mass is equal to 18 grams. All right. Now that's not your answer. So if it was the final answer, I'd flip it around and make it look all pretty. But that is worked out. What we've got here is the mass of CaCO3 reacted. We're told in the experiment table that there was 25 grams added to the reaction. And we were asked to find, as the final answer, calculate the mass of impurities. So it's a little bit squished here. So therefore, mass of impurities equals 25 minus 18, which is equal to 7 grams. And that is the final answer. Okay. So I hope that's helpful. There's a couple of other questions for you to download and practice. And that is the name of the game. So have fun. Cheers.